Hi there, Mr. Lees here, doing the SQA Higher Mathematics paper from 2019, paper 2, and we're on question 5, where you have a graph of a cubic function, y equals gx, they call it, with stationary points at x equals -2 and x equals 4. So on your diagram in your answer booklet, sketch the graph of y equals g dash x. So this is gx differentiated. So they want a sketch of the differential of this graph, or to put it another way, the gradient of this graph against x. So they want a sketch of the gradient of this graph against x. So the very couple of things to consider is that they tell you that g of x is a cubic. So that means that the highest power of x is 3. That means that g dash x, the graph we're trying to draw here, must be 3x squared or something similar to that. In other words, the highest power of x is going to be 2. And what do graphs with x squared being the highest power look like? They are parabolas. So the graph we're about to do is going to be a parabola. Right, so the first thing to do here is to look at the graph. This is the original one here. And we look for the parts of the graph that have a gradient of 0. So this here has a gradient of 0. So our g dash x goes through that point there. And where else has a gradient of 0? At this point here. And that is where x equals 4. So our parabola is going to go through -2 and 4. So you can see here with this broken line here. And parabolas, of course, are nice and symmetrical. That means that the turning point of a parabola will be below x equals 1. 2, 3, 4, 3 that way, 1, 2, 3, 3 that way, yeah. So that is the turning point of your parabola there. So that is your graph of y equals g dash x.